Hi everyone. Today's lesson is on properties of the definite integral. We'll be spending 2 days on this topic, and look at your calendar. Oh my gosh, I'm sorry. Look at your calendar to determine what the assignment should be for tonight's lesson. Okay, so when we talk about properties of the definite integral, we're really talking about how you can solve an integral that it has bounds and what are some of the extra properties that you can apply to it. So you're going to see here a few of those properties. So the first one is one that you've already done, this order of integration. So this order of integration means how do you apply the bounds of A and B? And then this multiplication or division by a constant is very similar to what we do with derivatives. So let me just show you both of these. So when you integrate a function from A to B and you get the antiderivative, because remember they mean kind of the same thing, you evaluate, which we've already talked about, by substituting the top bound in first and then the bottom bound in second, and you subtract the two. So the integral of f of x from A to B would be the antiderivative of f of B minus the antiderivative of f of A, okay? And then if you're multiplying by a constant or dividing, whatever, you've got a constant out front of the function and it's inside the integral sign, so it's in this argument area here. All you really have to do is just either pull that k out front, or actually multiply the k to each term. So either way would be fine. You could add, you could go ahead and distribute the k as well. That would work in the same way. But it's just a constant, so you just multiply the constant even to the final result. Okay, the next two are sum or difference of two functions, and then this additivity rule. So let me show you both of, there's the situation here. So let me show you the difference in what's going on here. So this one over here has two functions added together that have the same bounds, right? So from A to B of f of x plus g of x, versus this one over here, it's the same function, but the bounds are different. But what's important to notice about the bounds here is that the top bound here is the same as the lower bound over here. So these two things match. This is a big deal that you notice this situation. If these two things don't match, then you can't really do this situation or work with this situation. Okay, so here would be the answers to these two things. So the first one would just be take the integral of each function separately, or if it's just two functions that are polynomials, you could do it all at one time. It doesn't really matter, but it's going to be two different results. And then for this one here, then because the bounds are the same at the upper as the lower is, then you can combine it into one integral of the function going from the lower bound here to the upper bound here. Okay, next. And remember, of course, to pause if you need to. I feel like it might be kind of fast because I've already got it written up for you. So again, remember, you can always pause. Okay, so now we're going to practice these rules here using this information at the top. So it says that from A to B for f of x, you get r, and from A to B for g of x, you get s. So same bounds here, but two different functions. And that's really important that you see the difference in those. Okay, so here you're going from A to B of f plus g. That should be pretty obvious that that's going to be r plus s. And the same thing here. You've got from A to B of f minus g. So that should be pretty obvious that it's going to be r minus s. And then this is that multiplication rule. So you've got 3 here multiplied by the f of x function. You could pull that out front if it's easier for you to understand. But either way, the answer is going to be 3 times the answer for from A to B of f of x. So this r part here. Now this one's a little bit different here. So you do need to recognize that this could be two functions separated. So let me actually write that as an option here. Get that here. So this could be the integral of 3 plus the integral of g of x separately. And the integral of 3 then is really like a horizontal line that you're finding the area underneath, or you're integrating that and getting 3x, if that is something that makes it more understandable for you. So what ends up happening is you have this little area. I could even draw a picture here. So from A to B, under the line 3, your height is 3, and the base would be B minus A, which is what I've got here. So like base times height. You could also distribute the 3, doesn't matter. And then, of course, we know this part is already S from up above. Okay, so this is just the multiplication and addition rule at the same time. So 2R plus 4S. And this is the multiplication and subtraction at the same time. So 7R minus 2S. All right, the next part's a little bit trickier. So I'm going to have some pictures to go along. Oh, nope, I'm not right. That's the next slide is the trickier part. I think this will still be okay. So you just have one piece here that is just from A to B of f of x is r, but then we're changing around the order or what you've got going on with the sign out front. So it was really paying attention to the sign of the answer. We have talked about in the past that if the bounds are the same, if it starts and ends in the same place, your answer is going to be 0 because you don't have any area to find. And then if you switch the bounds around, so you go from B to A, well, that's the same as if you went from A to B but made the answer negative. Oops. I'm just trying to use my mouse to do this. So from A to B of f of x here would then be taking your value of r and making it negative. And now from here, that's going to be the same answer because, again, you're taking like that negative and factoring it out front. So r and make it negative. And then this is going to be a double negative because you've switched the order and you've put a negative here. So 2 negatives make a positive. So 0, negative r, positive r. Okay, so now this is the part I was thinking about here. So it's really important we pay attention to the order of which is the lowest values to help us out. So from A to B is r. It doesn't matter if A is bigger than B or not. That's the value we're getting is r. And then from B to C, you've got S. So you could see that if you just, like in part number 1 here, I should say, if you just think of A being less than B being less than C, if you go from A to B, you're going to get R for your area, and from B to C, you're going to get S for your area. So therefore, from A to C will give you R plus S. So that one should make logical sense because the bounds are kind of going in the order as the signs are here, or the order that the X values are going in. Okay. Again, pause if you need to. So now part 2, you've got C is less than B is less than A. So we've switched the order of the X values, but we didn't switch the order of the actual integrals. So I'm going to show you what I have here and how I wrote it out, and then we'll see what why the answer is what it is. So I just put CBA on the x-axis. I drew out this little whatever f of x function that could represent it. And so then I looked at the picture here. So if I'm going from C to B, well, that would be the opposite of this up here. So that's negative S. And if I'm going from B to A, again, that's also the opposite of what's here, which would be negative R. So these regions based upon this up here are negative R and negative S. But the thing is, we're trying to come up with from A to C, which is actually going from right to left. So in order to figure out A to C, you need to actually think of it like this. You need to think of it as switch it from C to A and make it negative so that we're going from left to right. So if I go from C to A negative, well, then I take the answer that I got originally from these two little areas, adding them together, and then make the whole thing negative, and you get S plus R. Okay, number 3, now we've got C in the middle. These are the ones I think that are a little bit more confusing. So let me uncover this, and I'll have my picture drawn here for you. So I'm going from A to C to B, okay? And it's a little bit trickier. So instead, what I decided to do is down here, kind of make look at the integrals that I'm trying to find. So if I'm trying to find from A to C, that means I first need to find all the way from A to B and subtract what I get from C to B. So find this big area and subtract the small area. So from A to C would be from all the way from A to B minus from C to B. Okay, so, well, now I can look up above and see what I have. Well, from what I have is I know that from A to B is R. So this is from A to B, and I'm subtracting. And then from C to B is like negative, right? So from C to B is a negative S here. So then when I do R minus a negative S, well, look at that. I get R plus S again. Okay, that's supposed to be an S, not a 5. It looks like a 5. Let me see if I can redraw that. Negative S. Okay. And then the last problem, again, is going to go from B to C to A, but we still want from A to C. Okay, so I tried to do this the same way. So B to C to A. If I want to know from A to C, oops, that's actually this way. So from A to C is actually going to have to be, this is going to have to be flipped around. But I do know I'm going to have to find, think of it going backwards. I'm going to go from A to B and subtract off C to B. So I'm going backwards with my thinking on this, and then I'm going to switch the sign at the end. So I'm going to go from, if I want this little part right here, this A to C, I have to go from A to B first and subtract off from C to B. If that makes sense. I hope that makes sense. Okay, so let's look at what I did down here. So I feel like maybe I have one of these in the wrong order. So let's make sure that's not what's going on. So I start off with switching my, I think I said this backwards. I think I said A to B and I meant to say B to A. I think I looked at these backwards up here, but not backwards down there. So instead of me trying to redo this part of the video, I'm just going to fix what I was saying here to make sure you understand. So you can go backwards, which is what I was pointing at here. You could go from A to B and subtract off from A to C to get from C to B, okay, like that. Like you can subtract off the parts to get what you need, or we can flip the order around so that they match what we have. So it kind of depends on how you want to look at it. So to do from B to A, which would be this long part, I'm going to switch it around and rewrite it as negative A to B, which is negative R. And to get from B to C, well, I already know what from B to C is. I'm subtracting it, that's positive S. Okay, so I had to switch this one. This had to switch the order. This order stayed the same, but I had to subtract off. And then I have to switch the order of this thing so that it goes in the way that I'm looking at, I'm used to looking at it. That becomes a negative, which switches the signs of these two to get you R plus S. All right, hopefully that makes sense. All right, and then I've just got the answers to these 6 here so that you can kind of look at them. Hopefully my handwriting makes sense because I was just using my finger instead of the stylus. So some of these are pretty easy to figure out, but the ones at the bottom are the ones I want to focus on. We technically cannot determine these, and these are mistakes that I know students will make on the test later on. So for instance, when I look at from 0 to 1 of f of x, the temptation is for you to take half of 5 to give it as the answer, because from negative 1 to 1 is 5. Therefore, from 0 to 1 must be half of that. But the only time this would be true, the only time I could say half of 5 would be if I told you that f of x was an even function. So if f of x and g of x were even functions, then you could take half or double, etc. Okay, etc. I think that's correct. I'm not sure. Okay, but because this is not an even function, you cannot take half or double or any of those things. So like here, when we look at f, so f is asking you to add f and h. But h is not defined from negative 1 to 4. It's only defined from negative 1 to 1. So I can't separate that out. F is defined technically from negative 1 to 4. So I could find the f part, but not the h part. And then the same thing here. This looks like you would want to double it because you're going, instead of from -1 to 1, you're going from -2 to 2. But because, again, h is not necessarily an even function, even would mean to be symmetric across the y-axis, which would allow you to have the same area on the left side as you have on the right side. You can't really determine anything about what's going on with the function. And for that matter, you can't even determine that it would be doubled anyways, because you don't know if this is going below or above. You don't know what's happening with this region. So you really cannot determine anything about this. All right, go ahead and start on your homework, and then when you can ask me questions tomorrow. Have a great rest of your day.